Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's step 1, here's step 2, here's step 3. Your challenge is to predict the number of squares in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of squares in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see how far you can get. Okay, this is kind of an interesting looking pattern. I'm going to call this a mouse head. There's the head and there's the big ears of the mouse right there. And that's 3 squares that make up that mouse. And then it looks like in step 2, the ears are growing. And in step 3, the ears are growing too. Okay, so right off the bat, I'm thinking this is probably a quadratic pattern because we've got squares that are getting larger. So I think that's going to be quadratic. If I were to predict step 4, let's see, the ears are 1 by 1, then 2 by 2, and then 3 by 3. So I would expect a 4 by 4 ear, another 4 by 4 ear, so 16 in each of those, and just 1 down here. So 16 and 16 is 32, plus 1 is 33. So my prediction for step 4 would be 33 squares. Let's take a minute to examine the numbers and see if it verifies our idea that this is a quadratic pattern. So I'll put the step number in a chart and the number of squares. Okay, and in step 1, it's just those 3. And in step 2, 4 and 4 is 8, plus 1 is 9. And in step 3, we've got 9 and 9, 18, plus 1 is 19. And then in step 4, we're predicting 33. So let's take a look at the differences here. So this is 6, and then this is 10. And let's see, this is 14, right? Because 4 would get you to 23, and then 10 more. So we're not getting a constant in this first set of differences. So we know it's not a linear pattern. Let's take a look at the second set of differences. So 10 minus 6 is 4, and 14 minus 10 is 4. We do get a constant there. So this is telling us it is quadratic, so there's going to be an x squared somewhere. And actually, we know the coefficient of that leading term. It's the difference, the second order difference divided by 2. So 4 divided by 2 is 2. So 2x squared should be our highest term in that equation. And I think this knowledge is going to get us pretty far along in that equation. Because the 2x squareds, well, here's 1 and here's 1, and just 1 left over. Here's an x squared, here's an x squared, 1 left over. Here's an x squared, here's an x squared, 1 left over. So I think it's just y equals 2x squared, that's the ears, plus the head is just that 1. The head stays the same size. So let's test this though. Let's make sure this actually works. So in step 1, we'd be saying y equals 2 times 1 squared plus 1. And that would be 2 plus 1 is 3. Yeah, that works. How about here? Y equals 2 times 2 squared plus 1. Well, 2 squared is 4 times 2 is 8 plus 1 is 9. And that's what we had in step 2. How about in step 3? Y equals 2 times 3 squared plus 1. So 3 squared is 9 times 2 is 18 plus 1 is 19. Yeah, checks out. So I think we can be pretty confident that our equation here is correct. Y equals 2x squared plus 1. So now that we've gotten this far, what remains is just to calculate the number in step 43. And we're going to plug 43 in for x. So y equals 2 times 43 squared plus 1. And 43 squared, I've memorized that by now. That's 1849. So we multiply that by 2 and add 1. And let's see, 1849, that's going to be 3698 plus 1. So 3699, 3,699 squares in that step 43. That'd be some pretty big mouse ears. Well, how did that go for you? Did you see right away that this was going to be quadratic? Let me know. Thanks, everybody.